This is Rob Gray from ASU and PerceptionAction.com. Today on the Perception in Action podcast, my interview with Joe Baker, professor in the School of Kinesiology and Health Science at York University in Canada. Hi everyone, welcome to the Perception in Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. In today's episode, my interview with Joe Baker from York University. Joe received his PhD in applied exercise science from Queen's University in Canada, and also did a postdoc there looking at exercise epidemiology. He currently heads the Lifespan Health and Performance Laboratory at York, and has also held visiting professorship positions around the world. To say that Joe is a prolific researcher in sports science is an understatement. He has published a large body of work including several books, book chapters, and journal articles covering skill development and physical activity across the lifespan. In our discussion, we cover topics including how good are we at identifying talent, early specialization versus diversification, designing effective learning environments, retention and transfer of sports skills, and are sports good for our long-term health? Hope you enjoy.
Not 10 years ago, I was a child. I was a good boy and you let me go. Now I'm on a talk show. So
today my guest is Joe Baker, professor in the School of Kinesiology and Health Science at York University in Canada. Thanks for taking some time to talk with me, Joe.
Well, thanks, Rob. I'm a big fan of the podcast, so I'm excited to be here.
Oh, thank you. So to kick things off, I'll ask you my favorite question. To start off with, can you tell us a little bit about your background and how you got interested in sports science?
Yeah, I was an athlete for a while and a late starter to sport. I was a martial artist when I was a teenager, and then I got interested in triathlon and raced fairly seriously in triathlon for about 10 years. And during that time, I got interested in performance and sort of how we can understand performance better. And I never really thought of it as a career. My undergrad degrees in physical education, and then my master's was in health education. And I did a master's thesis on adolescent substance abuse, which was interesting, but also not something that I saw for a career. And in between my master's and PhD, I had the opportunity to go and work in Australia with Jean Cote and Bruce Abernathy. And it was like a light bulb moment. As soon as I started working with high performance athletes, it was like, this is what I want to do for my life. And it's been full steam ahead ever since that. That was 1998. And it's almost 20 years now.
And I know you still do a fair amount of exercise science kind of research as well as sports science stuff too.
We have another program of research that looks at aging, and I think we'll get into that a bit today. Yeah. So in your research, what I really like is you kind of cover the whole spectrum from identifying talent to developing it to what happens when you kind of tail off at the end of your career, which is where I am kind of starting. But so what I thought would be good is to kind of go through that step by step in talking about some of the things you do. So I know a good place to start maybe is you had a recent study where you looked at how we can predict talent by looking at some of the draft results and things in different sports. So can you talk a little bit about that? How good are we at predicting who's going to be the next sports superstar? Yeah, it's a great question because it's a one that we, if we look at where we've been and what we've talked about over the last couple of years, everybody wants to talk about the talent question because it seems to be so important and so foundational. But all the evidence we have is we're terrible at identifying talent. And the further back we get, the worse we are at it. We looked at the professional sports drafts, which try to identify talent relatively late in athlete development. They wait until sort of the college age, and they try to predict who's going to be successful a couple years later. And even they're terrible at identifying talent. And so if we stretch that time span out, now start to look at the idea that we could identify it in childhood or adolescence just makes no sense whatsoever based on any evidence that we have. Yet we have an entire sports system that's based on this concept.
Yeah, no, it's crazy. And I know you tried to relate kind of was it the length of people's careers to their position in the draft kind of?
So we looked at games played, and the reason we did that was because different teams will have different ways they approach the game. And so If we look at the NHL, for example, some people they might play an enforcer role. And so it's hard to measure that with a performance statistic. Mm-hmm. But we came up with the idea that if you're fulfilling your role, you're going to play games. And so games kind of became this catch-all measure of a person, I guess, value to the team. And so we looked at just in terms of total games played, how did that correlate to the draft? Or to the round that they were drafted in. And we found that the league that does it best is the NBA, and they account for about 17% of the variance. Mm-hmm. But they only have a 2-round system, which really limits the variability in the athletes in that system. And the worst is baseball, but that may be to be expected because baseball has an entirely separate AAA development system that kind of is the filter between who goes from the draft to the majors. Mm-hmm. So it's a little bit different and it was kind of surprising, but the NFL and the NHL, how poor they were was a bit of a surprise to us.
Mm-hmm. Yeah, no, it was, to me, look at it, I figured they'd be bad, but the numbers are really shockingly low. Yeah. So digging a bit deeper into the talent ID, I know you've done a lot of research on something I've talked a fair bit about recently, the relative age effect. So I was wondering, where do things stand with that in your view? And, what can we do about it?
Yeah, it's still there. And I think the surprising thing is how persistent it's been since researchers in sports science have known about this since the mid-1980s. And the sort of historical stuff we've done shows that there's no indication of it getting smaller, even though coaches say they're aware of it. We don't see that this effect is getting smaller in any way. For me, the thing that's more interesting now is the kind of nuances that are starting to emerge. So, we've done a couple of studies and others have done other studies that have shown that it might not be so bad to be the relatively youngest. If you look at who gets drafted into the NHL earlier, who makes more money in professional soccer, who has a longer career in professional handball, it's the kids or the athletes that are in the fourth quartile, which we sort of for decades have set up as being this disadvantaged group. And so it seems like there might be some advantage to being in that group if you're able to survive, right? If you're able to survive the athlete development process and stay with this group, which is probably larger, faster, certainly older, then that might be a more beneficial environment for developing superior athletes, which is kind of a really neat nuance to this effect. And so, one of the questions we're always asked is, how do we get rid of it? And so these results suggest that for a certain group of people, we may not want to get rid of it because it's really good at developing high performance elite athletes.
Yeah, no, I think that's the kind of the reversal of the effects really interesting. Putting people through this, kind of making them tougher makes it hard at the start. But another thing I know you looked at that I've been really interested in is kind of the laterality question, being left-handed. I know you've done some work both on kind of once you develop what kind of advantages it gives you in terms of anticipation. But I think you've also done some work on kind of how it relates to a talent ID, right? Can you talk a little bit about that?
Sure. And this research goes back to the sort of the surprising distribution of left-handers in interactive sports. And so I think Florian Loffing and Norbert Hagemann have done a lot of work on this in tennis and showed that at one point, there's 35% of the top 100 tennis players were left-handed, even though there's only 10% of left-handers in the population. And so suggests they've got some sort of performance advantage. And there's a couple hypotheses for why this occurs. The one that makes the most sense is perceptual familiarity, that we get really good at anticipating right-handers because we see them 90% of the time and comparatively less time and exposure to left-handers. And so we get, the schemas and the kind of mental representations we have are less developed for lefties, so they have a performance advantage. And the reason we're confident in that hypothesis is a study that I did with Jörg Schorer and some of his team in Germany showed that when we bring them into the lab and we have them do some video training on just left-handers, we can remove the advantage. And so from a talent ID perspective, it looks as though lefties have an advantage because just of their rarity. For me, I think the more exciting thing in terms of identification and development is the fact that if we want to provide a level playing field for both right and left-handers, we need to redesign the way that we train anticipation and decision-making skill by having them see more left-handers, whether that's through video training or just more time on the court with left-handed players. And I think tennis has caught up to this, because if you look at distributions of right and left-handed players, it's much more balanced now than it was, say, 10 years ago.
Yeah, no, I agree. I think it's really interesting you kind of identified this way to address this, but some seem reluctant. Like baseball, they seem, okay, you're going to be a platoon player, right? You can't hit left-handers. So that's just a fact. We're not going to try to make you better at it. So it seems really interesting. I guess the final point I want to talk about is a debate that's really kind of been hot for a while, the specialization versus diversification at an early level. What kind of things have you found in your research and your thoughts on that debate?
Yeah, it's a heated debate, and if you look at, certainly in Canada and Australia, if you look at the way they've designed their athlete development models, they've switched to now focus on emphasizing this diversification, and a lot of that comes out of research that we've done, and certainly that Jean Coté has done, showing that the more likely trajectory for an elite athlete is somebody who has a broad sport participation base. And so, the more I think about this, and I'm reading a lot in this area, the more I wonder whether it's problematic to advocate for that approach because of how the sports system has changed, right? I think it's always important that we remember that when we look at people who are elite athletes now, we're looking at the way the sports system was when they were developing, and it's a different sports system now. And so when, one of the things that we're talking about in my lab is approaches that come out. Sport Canada has one that says that the best thing you can do to help your kid become a high performance athlete is to have them involved in a lot of different sports when they're young. And I think the sports system is designed to make that really hard for parents and for kids. And it certainly makes it hard for parents who are at lower levels of socioeconomic status, where almost all sport involvement now is paid involvement. And so I think when you advocate those kind of positions, that diversification position, as much as there is evidence behind it, I think we make it really hard for a certain group of people in our population to fulfill that goal. And so one of the things that we're working with is, the evidence shows diversification is the way to go, but how can you get the same benefits that we get from diversification, whether it's increased intrinsic motivation, increased variety, variability, better love of sport, all sport, well-rounded athletes, all those kinds of things. Can we do that with a single sport approach? And certainly in North America, the single sport approach is the dominant approach in most sports systems at the highest level of competition. Soccer, ice hockey, football, they have year-round training programs, and you can't just say, I'm going to stop for 6 months and play a couple other sports.
Yeah, no, I think you're right. There's so many challenges for the kids and the parents that want to have a career. You're right. The historical, like ice hockey, I think myself, when I played ice hockey, there was not an option to play in the summer. We played soccer because you couldn't play ice. There was no leagues. Yeah. So we were diversified. We didn't have a choice. It didn't matter. Now there's all these camps you can go to and in front of scouts, and it's really hard to resist that urge. Yeah.
Yeah, and we do a lot of work with amateur and lower level, the bantam, peewee level ice hockey here in Canada, and their season ends in April, and training for the next season starts in June or July with selections. And so, where do you squeeze another sport in there? Yeah,
no, you're right. On paper, it sounds good, but the practicalities of it needs to be addressed still a lot.
Yeah, and I think the problem is when sport policies developed on research that worked in the past and they haven't really looked at how do we rejig it so that it works with the system we have now, I think it can create all sorts of problems.
Yeah, no, I think that's going to continue to be an interesting topic. So turning now to the talent development. Okay, so we've identified you as a talent and then we want to develop it. I had Anders Ericsson on a few weeks ago, and he's put it one way, he's kind of doubled down on deliberate practice theory in a way, which, it does have a lot of support. I know you've done a lot of work on kind of the different aspects of talent, and what are your kind of views on the role of practice and deliberate practice? How does it fit into the big picture?
Yeah, when we work with high performance groups, I always sort of start off with deliberate practice is probably the number one thing that you have control of as a coach, as a learner. And so you've got to pay attention to this concept. And then we sort of go drill under the surface and talk about other things that could affect it. And for me, the interesting thing in how the discussion about deliberate practice has changed over the last 5 years is is kind of the way we look at performance in general now. We don't talk about, this proportion of it is nature and this proportion of it is nurture. There's kind of a combination of all of these things. And I think that deliberate practice is the same kind of concept. You can't remove the genetic component that might help you practice deliberately from deliberate practice. We look at it as this very environmental, nurturist kind of concept, but your ability to put in 10,000 hours, or, Erickson hates that number, but your ability to practice for a decade in high level, high quality training is probably based on a foundation of genetics. Mm-hmm. So for me, the really cool supporting evidence is for a gene called COL5A1, which it encodes for all sorts of things. But one of the things that's interesting for us is it encodes for elasticity of your tendons. And so if you have one marker, you have nice, long, elastic tendons. If you have another one, they're a little bit stiffer. And so that gene would have to affect the amount of hard training you could do as a sprinter, for example, before you ruptured your Achilles tendon. And so if we only look at hours of training, it looks like that's the variable, but it's built on an architecture of genetics and biology that predispose people to that kind of training in the first place. Mm-hmm. And there's some other evidence that suggests that maybe motivation and initial attraction to these kinds of activities has a genetic basis as well. And so for us, we're trying to build models that incorporate both of those things, not to sort of discount the value of practice, because if you throw all these variables in a statistical soup and try to see which one predicts the greatest amount of variance, practice is the number one variable. But practice isn't its own thing. It's got all sorts of layers and all sorts of antecedents that need to be in part of the discussion.
Yeah, and that kind of brings me to the next, I think a way that we've changed is gone beyond the individual athlete to talk about the learning as a learning environment. And so I know you've done some work on that. You had a recent study looking at kind of sibling relationships. Can you talk a little bit of some of that work?
Yeah, that was my PhD student, Mel Hopwood's work. She came to Canada for a few years and was enrolled with Victoria University in Australia. And so we had this really neat possibility to collect high performance data between Canada and Australia. And she collected a really great data set of athletes at different levels of skill. And what she was able to find with the siblings was that more elite athletes had a greater likelihood of having siblings who were older than them that sort of played a role model. They achieved pretty good standing in their sport. They didn't achieve as high as the elites, but they sort of created a path for that person to follow. And from that, this idea that it was a benefit to be a later born sibling in a family unit seemed to emerge as a pretty powerful finding there. And we have some parent data that shows very similar findings, that athletes who have make elite standing have parents who were high performing athletes as well. Mm-hmm. And so this idea that the environment that they grow up in, and again, it's hard to dismiss that there might be genetic factors there in that family unit as well. But from what you can control perspective, that environment that they're growing up in seems to be much more suited to high performance than to just say average levels of participation. Yeah.
And I think maybe, you can link that in a way to the relative age. From what I've seen, younger siblings often end up playing with older kids all the time because they're playing with their older siblings' friends. I know I can think of cases like that and with people I know.
Yeah, and that was one of the things that we're trying to do with Mel's data set, because one of the things, obviously these things are going to have connections with each other. And so one of the things we wanted to do with Mel's data set, and she designed a standardized instrument for collecting athlete training history, is to design a database that's going to have the statistical power so that we could look at those kind of combinations of effects. So if you're relatively younger and you have older siblings, is that enough to diminish the relative age effect? For me, those are the real exciting research questions that we haven't been able to look at yet because we haven't had sample sizes large enough.
Yeah, no, that sounds really interesting. So you're still collecting some data on that? Yeah.
Yeah, we're still collecting. Mel's gone on. I think she's head of talent ID for Parasport New Zealand now, but we're still collecting data with that instrument. And the idea is it's just going to go into a larger, ever increasing database that we're going to use for some of these larger analyses.
Mm-hmm. So I guess finally, within the talent development, I know you've kind of also looked at kind of the interesting question of transfer of training. Is there a way you can shortcut some of this development process? Yeah. And I know you've looked at, transfer, does the quiet eye transfer between sports? And what are your kind of thoughts on that? And can you talk a little bit about the ability to transfer between sports?
Yeah, the idea of transfer, when we started looking at it in the late 90s, it was kind of, there was a hard stop that perceptual and cognitive factors are very domain specific, and there's very little transfer between domains. And so we did one of the first studies that showed that pattern recognition abilities can transfer between sport domains if there's similarities between we looked at field hockey and basketball, and they had transfer between those sports, but not with netball, which is set up in a completely different way. And so that started us along a line of research that sort of looked at what factors are transferable and sort of opened up the debate again that maybe there are things that we can transfer between sporting tasks. And I think Australia ran, not based on our research, but at the same time, they were running along a parallel path looking at how they could move athletes that are high performers, maybe not at the international level, but at the national level, and move them into sports where they could take advantage. Bobsleigh's been doing this for decades, where they bring sprinters in and try to get them to be pushmen on the sleds. And so this idea of talent transfer has become this monster in terms of athlete development, which I think is a great concept. I actually think that it has more potential than is being utilized right now. The model that we're working on right now in terms of the benefits of talent transfer are, what if we go even earlier? If you look at the people who are eliminated from an athlete development system at different stages of development, when we're talking about the national to the international level, that's a really small number of people. But if you look at who's eliminated from, say, a high school basketball program because they don't make the leap to the college level, we're talking about sometimes hundreds of thousands of kids that aren't being able to play basketball anymore. So, well, how come we can't move them to a handball program? I'm sure the U.S. could use a grassroots handball program where they could just get the people from basketball to move over to that sport. And so if we could facilitate that kind of transfer, I think that the idea would have even greater payoff than we're seeing right now.
Yeah, I agree. And I think it's so important because, just keeping people physically active. So many people play sports in high school or hit a certain level they reach and then they're done. I think it's really important. And, in education, like we're putting a lot of effort here into if you don't make it in one major, like in engineering, we show you how you can take what you have and transfer it into social science. So so that would be an interesting thing. If, here's the skills you have that would be good in another sport. That would be really interesting.
Yeah. And from a social perspective, at that adolescent period is where we see the greatest decrease in physical activity and sport involvement. So why not, you would think there'd be some political will to investigate that question as well, because it's got payoff for, medical and healthcare costs in the future.
Yeah, no, I think that's really important. And then finally, moving towards the end of the developmental pathway, I know you've also looked at retention of sport skills in master's athletes. I know that's a really tough thing to study because trying to do longitudinal, but I think you've done some really interesting things where you compare the relative difference between elites and lesser skilled at different ages, right? And see if that difference maintains. Can you talk a little bit about that?
Yeah, that work was, we started that back when I was a PhD student at Queen's, and we were looking at high performance golfers. My lab mate, Sean Horton, who's now at University of Windsor, was a high performance golfer in his youth. And so we just started exploring this question of how do golfers maintain their skill over time. And we had a really great statistician on the project who was able to control for the changes in how leagues advance over time and how golfers in those leagues might change over time. And so we were able to control for those kind of things. And what we found was that, no surprise, aging exists. People, decrease their skill as they get older, but the amount of decrease was surprisingly small. And in some areas of golf, there was no decrease. Putting skill didn't change at all, for example. Driving distance, which is a bit more about generating biological power, decreased the most, but it looked like golfers were able to compensate for those kind of decreases by becoming more accurate. And so their scoring average wouldn't change very much at all. So, the reason that golfers, as they get older, stop winning tournaments isn't because they get worse. It's because the field gets better. And so for us, that was really interesting. And it opened up a whole program of research looking at maintenance of skills over time. And so now we've looked at perceptual cognitive skills in handball goalkeepers, and we found that goalkeepers, they maintain the ability to find the appropriate perceptual information to make the right decision. They just lose the motor ability to move to intercept the balls. And so we think this has got a lot of implications for policies as we get older, like driving. The interesting thing that we're looking at is how our perception of aging affects our behavior. And so we think that a lot of people get worse at driving because as they get older, they drive less because they think they're going to be worse. And so that feeds into this cyclical relationship between involvement and skill. That if you had a different message, which is one of the things that we look at in our aging research, if you had a more positive message about getting older, that, as you get older, you need to practice more, not less, then maybe we would see these skills maintained more. We certainly see it in the golfers. We saw it in almost every type of perception and motor skill where it takes a long time to acquire that skill. They're very robust to aging as long as practice continues. It's when they stop practicing that we see the decline.
Yeah, no, I think that's a really good point. And I think, what I've seen too is in driving and in sports too is often you can, just by changing kind of your strategy, you can take advantage of some of the, you have more knowledge, you're better at predicting what's going to happen. So you can move a little earlier or, know, that kind of thing. So to tell people that it's not this dead end, that you can adapt. Because you have this mental model or knowledge or whatever you want to call it that you've built up that's so powerful.
Yeah, and certainly we see that a lot in baseball, right? That the hitters become smarter as opposed to, they don't change a lot other than the way they approach a pitch. And it's, whether that's based on conscious strategy or just implicit learning or whatever, we've seen that the extent to which certain positions in baseball can have longer careers than they've ever had before because they approach the game more smartly. And we've seen that, the Rio Games is another example, the swimmers and almost every element of sport where there's a long-term learning aspect to it, that people that are able to engage in that sport for much longer than they ever have before.
Yeah, no, it's amazing. That's a really important point, I think. And along with the aging too, we all know that being physically active throughout our life is good for us. But what have you found about being a highly competitive elite athlete? Is that good for us in the long run?
Yeah. So I have a PhD student who just finished his whole PhD, Surgeon Lemez, who's at University of California, LA. He looked at the long-term health and longevity consequences of being an elite athlete, and almost every element of the health that he looked at, it was better to be an elite athlete than to be the average person in a population. The obvious question is why, and we have no idea. It could be that they start out with superior genetics, which allow them to be great athletes in the first place, so they have a positive health phenotype and genotype. Or it could be that the amount of money they make as a high performance athlete allows them to have better health care as they get older. Then maybe they maintain their physical activity habits better than the average person as they get older. We don't know, but it does seem to be an advantage in terms of absolute longevity and lifespan. It does seem to be an advantage to come from an elite athlete background. But there's other elements of health that we have to consider, right? Absolute quantity of life isn't as important as quality. And so if these athletes are spending the last 2 or 3 decades in ill health and chronic morbidity, those kind of things, then maybe that's not what we want to aspire to. And so those are the questions that we're exploring right now. But it does look like, for some reason, and we could probably pick a dozen of them, elite athletes have some advantage that allows them to live longer than the average person. And it's not small amounts. We're talking about massive amounts of increased lifespan.
That's really interesting. You're right. There's so many factors that contribute to that. But I just like the story. You hear so many things. Like, I'm a runner, so I'm so tired of people saying, "Oh, your knees are gonna be wrecked when you're older." I'm so glad we're changing that message to people.
Yeah, even the data that we looked at for the NFL, which is in the middle of this concussion crisis, it does look like they have an advantage in terms of longevity, which we found really surprising.
Yeah. So I guess the last question I have for you, Joe, you've talked about a few things, but I was wondering if you could just talk about maybe a bit about kind of your current or near future plans for research.
Yeah, we're still looking at this notion of talent. And for us, we do a lot of work with high performance sports now. And if we really want to test this empirically, we need to have a lot better data than we've got so far. And so coaches, progressive coaches collect data very religiously. And so for us, it's about how do we access it? And part of that is being connected with the sports. And so that's one of the things that we're really focused on in my lab is sort of breaking down those barricades between the science and the coaching, and being resources for them. It involves a lot of work with, just telling them what we're up to and asking them what their needs are, that kind of stuff. And so that's a big part of what we're doing these days. We still do a lot of work with older athletes trying to understand what kind of age-related declines can we expect. And I think athletes are the best populations to help us understand that question because they're highly motivated. They've trained for decades. They're probably training as hard or in the best environments as you can. And so they're the perfect group for helping us understand what we're capable of. And I think we're still sort of building these larger data sets to help us look at seemingly simple questions in more complex ways, like the relative age effect, like the advantage of growing up in cities of different sizes, the importance of early involvement in sport versus starting later. All those kinds of things are questions that we're continuing to explore.
No, that's great. Well, thanks for taking some time to talk with me, Joe.
My pleasure.
Thanks again for the great discussion, Joe. I'm really excited to see the outcome of those ongoing studies you talked about. To learn more about Joe's research, you can follow the links in the show notes. And he is also on Twitter at BakerJYorkU. Coming soon on the Perception in Action podcast, sciencing my way to being an ultra runner. This is Rob Gray from ASU. Cheers for now.
Now you're the